Dear students, in this session, we are going to talk about how to assign a R&S nomenclature for a chiral center. Okay. So, what is chiral center? So, chiral center in organic chemistry, we are generally talking about the stereogenic center of the carbon. So, carbon has 4 valencies, and this particular RS nomenclature was proposed by the scientist Chan, Ingold, and Prelong. Okay. So this is also called as Chan-Ingold Prelong rule. So first we need to understand what is a chiral center, then only we can assign whether you have a R and S configuration. Okay. So given a carbon with 4 valencies, it will be called chiral when all the substitutions are completely different. This is a very simple definition of chiral center. Chiral center is also called as stereogenic center, a chiral center. So a chiral. Okay. So it is called as a asymmetric center also. So there is no symmetry in the particular area. Asymmetric carbon, stereogenic carbon, chiral carbon. So these are the different synonyms or terminologies one can use for the indicating the chiral carbon. Okay. So first thing is the carbon should be chiral. Then only you will be able to assign RRS. So when a carbon will be chiral based on the absence of symmetry elements. Okay. So let us take one example. Simple rules. We will talk about the simple rules, and then we will take some examples and explain how to assign R&S nomenclature for a given molecule. As I said, we are talking about carbon. The carbon will have 4 substitutions or atoms around it, right? So what we need to do is we have to assign the priority numbers for all the 4 different atoms. So this is a sequence rule. So you have to assign 1, 2, 3, 4 for the 4 different substitution across the chiral carbon. In this case, for example, I have a chiral carbon here. Why do I call it a chiral? Because all the substitutions are different and there is an absence of symmetry element. Okay. So in this case, how do you give this number? So you follow the atomic number. Higher the atomic number, higher the priority for the given for the substitution. For example, the atomic number of iodine is way higher compared to the sulfur. So this is assigned 1. Okay. And then coming to, so we have a 4, hydrogen is the smallest one. So we have 1. So that will take the last number priority. So right away when you see hydrogen, you can give the priority 4. So that leaves you only 3 substitutions to be given the as a priority. So among this, iodine is in like something like an odd man out, which is having the highest atomic number. So you do the number 1, followed by chlorine, and then sulfur, SO3, sulfonic acid group. Okay, so this is how you are going to assign the numbers. So in the case of second, this particular example I will come later on. So first rule is whenever you have different substitution based on the increase in the atomic number, higher the atomic number, higher is the priority given. Okay, so this is what higher the atomic number, higher the priority. So that's the first rule. So the second rule tells you about if at all you have an isotopes within the, for example, in the case of hydrogen, you have 2 different isotopes. We have deuterium, we have tritium. Okay. So in this case, how you will assign the priority? For example, in this case, hydrogen is the least one for sure. You right away give the priority as 4. In the case of the bromine, it takes a priority 1. Then you have between carbon and deuterium. So carbon takes priority 2. So between hydrogen and deuterium, heavier isotope, okay, higher mass number, because when you are not talking about an isotope, right? So instead of atomic number, there will be a change in the mass number compared to hydrogen and deuterium. So higher the mass number gets the higher priority. So in this case, you will have 1 for the bromine, 2 for the CH3, 3 for the deuterium isotope of the hydrogen, and 4 for the regular hydrogen. Okay. So if the relative priority of these 2 groups cannot be decided, okay, for example, now you are talking about a carbon. So you're talking about the next substitution, and if the atomic weight is higher, you are giving the priority. So assuming that you have a tie, for example, take this instant, okay, this particular example, you have a carbon. So in the left hand side, you have an isopropyl group attached to the chiral carbon. In this case, you have a right hand side, you have a ethyl substituted carbon, okay, ethyl substitution. And here you have a chlorine, you have a hydrogen. So by default, hydrogen takes the fourth priority. So among this ethyl and isopropyl, how will you assign which will take the higher priority? So from this chiral carbon, I go for the first atom, that is carbon. On the right hand side also I move, again it is only carbon. So there is a tie between two carbons, right? So if you go to the next substitution from this carbon, I have two hydrogen and one carbon, right? So this carbon is attached with hydrogen 1, hydrogen 2 and another carbon, that is CH3. So this carbon is attached with 2 hydrogen and 1 methyl group. Whereas in this case, I have 2 methyl group and 1 hydrogen group. So obviously this takes a heavy weight, okay, and because of this the priority is given true for the isopropyl group compared to the ethyl group. So this priority, chlorine takes the first priority, isopropyl takes the second priority, ethyl takes the third priority, and hydrogen takes the fourth priority. Okay. So in this particular case, for example, now what is the difference between this example and this example? Now I have replaced the CH3 with the chlorine over here. Okay. So in this case, the chlorine takes the first priority, hydrogen takes the last priority. So between 2 and 3, you are talking about this carbon is attached with this carbon, whereas on the left hand side also you have only carbon. So carbon, carbon, there is a tie. Next to this carbon, you have the very high atomic number atom, that is chlorine, compared to 2 carbons. Okay. So obviously the chlorine takes the weightage higher as well as the priority. So chlorine takes the first priority, CH2Cl group takes the second priority, isopropyl group takes the third priority, and hydrogen takes the fourth priority. So when there is a double bond or a triple bonded compounds, how you need to visualize and how you need to assign the priorities. For example, in this case, I have C double bond A. Okay. So that means the carbon is attached with 2 bond with an atom A. So since you have 2 bond, that is a double bond, you envisage as not 2 single bonds, that is a carbon attached with 2 atom A. Okay. So you need to visualize. For example, aldehyde. This the carbonyl of the aldehyde should be visualized. This carbon is attached with 2 oxygen. So rest of the things you have to just calculate the way it is done, what we have learned in the earlier examples. So if it is 3, for example, triple bonded system, so this carbon is attached to A1, A2, A3. So you need to assume that this C triple bond C, okay, let's say this is an acetylene. So all the atom A, it should be considered as a carbon. So that carbon is attached with 3 different carbons. So we have to see this and compare with the your substitution which is in type. So based on this, you will be able to assign 1, 2, 3, 4. Okay, nomenclature. The priority can be very easily given based on these simple rules. Okay. So there are 3 scenarios. So as soon as you make this 1, 2, 3, 4, if it is coming, the priority is coming to the clockwise, this is assigned as R. When this is coming in the anti-clockwise, this is assigned as S. But usually to make a clockwise or an anti-clockwise, all you need is maximum 3 points. But if you have 4 points, okay, 4, because that is the priority we are given, right? 1, 2, 3, 4. So you can only take 3 best priorities. You have to keep the 4th one away from the discussion for the temporary to assign the R and S. Okay. So you have to give 1, 2, 3. If it is clockwise, you assign R. If it is 1, 2, 3 in the anti-clockwise, you assign S. But this configuration assignment will get affected based on the 4th substitution. For example, if the 4th substitution, because you're talking about a 3D structure, right? 4th substitution, 1 will be towards you, 1 will be away from you, 2 will be just on the plane of the carbon. So this is the general scenario one can think of. So if the last priority group is away from you, whatever you assign with the first three priorities, you just retain it. Let's say you have low priority, high priority. So whenever you see there is a clockwise rotation, you assign the R. When it is anti-clockwise, it is yes. This is case one. So for example, you take this example. So you have first carbon, and then the second, this carbon is attached with oxygen, right? That's the reason it is taking the priority one. Whereas in this phenyl, you have carbon attached to carbons one. So this takes the priority one. Phenyl carbon attached, so you have CC double bonded. So one carbon is attached with three carbons, so this takes the priority 2. Methyl takes the priority 3. Hydrogen takes the priority 4. Forget about fourth substitution. 1, 2, 3. It is going clockwise, so it is assigned as R. Okay. For example, in this particular example, this is 1, phenyl 2, methyl 3, D4, 4. Correct? So in this case, there is high priority to low priority, your movement is clockwise. Okay. So even if you leave the fourth substitution 1, 2, 3 the clockwise, and you are going to assign this as an R. Okay. So in this case, the substitution is away from the observer. So that's not a problem. Whatever the assignment comes, clockwise means R, anti-clockwise means S. Whereas if the fourth group, that is the fourth priority methyl, is below the plane, this is the second case. You assign all the substitutions, okay, as usual. For example, bromine takes priority 1, chlorine takes a priority 2, isopropyl takes 3, and 4. But the fourth substitution is towards me. Okay, always we just keep the fourth substitution away. That is 1, 2, 3, that is clockwise. But since the fourth substitution is towards me, you just have to reverse it. So that should be yes. Okay. So in this case, whatever we got clockwise means R, anti-clockwise means yes. Whereas in this case too, if it is clockwise, it should be R. Because your fourth substitution is towards me, it should be reversed, like yes, the opposite one. Okay. So this is how the general assignment goes. But for the fourth, there is a third option where your fourth substitution will be just on the plane. In the first scenario, the fourth substitution is away from the observer. The second case, the fourth substitution is towards the observer. The third case, you have substitutions just on the plane of the wave. So these are the three different scenarios. So in this particular scenarios, what you should do, since fourth hydrogen is on the plane, you have to either bring down or up. Okay, for that you need to do two exchanges. One exchange, if you are doing, then that will lead to a wrong assignment of the chiral center. First exchange. So in this case, OH is in the same place, right? There is no change in this one. Methyl towards me, there is no change. All we did is interchange between ethyl and hydrogen. In this case, hydrogen is on the plane, ethyl is away from me. So you did the first interchange of these two atoms, hydrogen and ethyl. So when you do two exchanges, then only the relative absolute configuration will be conserved. Okay. So the second interchange we need to do. So in this case, what we have done is, since the fourth substitution is away from the observer, we are not disturbing it. So we did the exchange of methyl. So methyl is towards me, hydrogen on the plane. We just shift now. OH is towards me and methyl is on the plane. Okay. So we have done two exchanges. Now, based on the priority 1, 2, 3, it is taking the anti-clockwise. The fourth substitution is away from the observer, so you are not going to change any configuration. That is, yes, whatever you have assigned, the configuration yes is retained. So I repeat, we have based on the fourth substitution, the priority 4, we have to do some adjustment. So there are three scenarios. If the fourth substitution is away from the observer, whatever clockwise or anti-clockwise you are getting, you just assign R and S for that. If the fourth substitution is towards me, If you get R, just reverse it to S. If you get S, you reverse it to R. The third scenario where you have the force substitution just on the plane itself, okay? So we need to minimum do two different exchanges, ensuring that the force substitution is either coming towards the plane or away from the plane. So that is the important exercise. If you're randomly exchanging, again you are bringing the hydrogen, okay, to this particular on the plane, then there is no meaning of assigning the absolute configuration RRS. So these are the few things you need to keep it in mind. So you just have to go like a chain, okay? So when you have a tie, you go to the next atom, next atom, next atom, next atom. So do you think there will be a scenario where both the substitution will have exactly identical substitutions? If that is the case, the carbon itself will not be chiral. Okay, so that is a symmetry. R and R, because both the groups are exactly the same, there is no chirality. If you want a chirality, the substitution should be different. Substitution may be different at one point. It could be the first point of atom, second point of atom, or the third point of fourth, fifth, sixth also. But it should be different. Otherwise, there is no chiral center in the first case itself. So if there is a difference, you will be able to identify by moving one atom at a given point of time and assign it. For example, in this case, I have methyl, I have ethyl, I have propyl, I have isopropyl basically, right? So just by looking at it, I can tell you this isopropyl take the priority 1, 2, 3, 4. But if you really wanted to go stepwise, okay, every single carbon you need to see. For in this is the smallest one. This will take the lowest priority of 4, right? So whatever this particular carbon, the green, this is CHH. The carbon attached with 3 hydrogens. In this pink dot you have carbon, hydrogen and hydrogen. In the green dot you have, so these 3 are in tie, right? The pink, green and the blue are in tie. So this takes the priority 4. So then you move to the next carbon. So this is the lowest priority. Then you move to the next carbon, and as you move along, you will see that the priority is there. You see a difference how many atoms are present, and based on this one, you give the priorities basically. So in this case, you have the blue one, you have hydrogen, 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 and the green we have one more carbon is there, right? So this will be the highest priority because you have more number of carbons. Whereas the propyl group will take the second priority, this ethyl will take the third priority, and methyl will take the fourth priority. Remember, the fourth substitution is towards the observer. So whatever the R and S you assign, you are supposed to reverse the absolute configuration you have assigned. Okay. So these are some examples you can think and then you can solve those. Okay. So I have just give the answers directly. So you can just look at the three-dimensional structures. Here hydrogens are not shown. You should always visualize the hydrogen where it is. If at all we are talking about the chiral center, and that also you need to assign appropriate. Okay.